for prime factorization, we need to leverage the program that we made earlier, or the function that we made earlier is prime. And so this builds on that. What is prime factorization? Well, if we have a number like 18, let's say n is equal to 18, then the way that it works is you find the first prime number that can evenly divide into 18. So the first prime number that we have other than 1 is 2, and 2 does indeed evenly divide into 18. So we go ahead and divide that, and that gives us 9. And then for 9, we figure what's the lowest prime number that can evenly divide into 9. And we try 2, but 2 doesn't work because it's not even. But 3 does, so we'll put a times 3 here. And then we'll divide 3 into 9, which gives us 3. And we repeat that process again and again and again. So 2 doesn't evenly divide into 3. 3 does evenly divide into 3, so we can print out a 3. And we divide 3 into 3, and that leaves us with 1. And that will be our ending condition. And this here is the prime factorization of 18. Right? So that might not be the way that you do it in your mind, right? If you were in algebra class and they said, what's the prime factorization of 18? Well, you might kind of just think about what times what equals 18, and you would think 9 times 2, and then you say, oh, okay, 2 can't break down anymore, so what two numbers multiply to 9, and then we turn that into 3 and 3, and then this here is the prime factorization. So it's more of an organic process, but if we want our computer to do it, then we need to follow the algorithm that I kind of went through when we started this video. So now the question is how can we get that to happen? Well, we need a couple of loops going on. The first one is the loop that's going through and iterating, right? So we have the number 18, we iterate to get 9, we iterate to get 3, and we iterate to get 1. And then we need another loop, right, on every iteration of this loop to scroll through the prime numbers to check which one is evenly divisible into 18. Right? So for 18, it's, luckily the first prime number was evenly divisible into 18. But it could very well be that n is such a number where the first prime number to evenly divide into n would be 17, right? And if that's the case, then it needs to go through 2 and check and say, no, it's not evenly divisible. And then 3, no, it's not evenly divisible. 5, no. 7, no. 11, 13, 17. Oh, yay, 17 is evenly divisible into 18. Is evenly divisible into not n, and so I'm going to print it out. Right, so we need a loop to check which prime number is evenly divisible into 18. All right, so this first loop here, we want to consider while or for, and it's pretty obvious that we need a while loop because we don't know how many iterations we need to run. Right, this n could be the number 2, in which case the prime factorization would just require 1 iteration. Right, and n could also be some extremely large number, in which case the prime factorization would require many iterations of this outside loop. So we don't know how many iterations, so while, and while what condition is true? Well, n is 18 and we want it to stop when n is equal to 1. So we're going to say while n is not equal to 1, or alternatively we could say while n is greater than 1, right? And then for every iteration we want to check every prime number, right? So in this case, I guess we also need a while loop because we don't know how many prime numbers it's going to take until we can get one that evenly divides into n. Right? So we could say while, and what would we do here? I guess we could say while. Oh, what can we say? I guess we could just say while true, and then we could break whenever we want to break it, right? And so in here, we're going to have a counter that's going to increase, right? So we'll have a prime variable equal to 2, which is going to be our first possible prime number. and we'll increment that inside of our while loop, right? And now the problem here is that when we increment prime, we need to increment prime by 1, right? So that we could check all the numbers from 2 up to infinity if required. And so when we do that, when we increment by 1, we need to check to see if it's actually prime, right? So that's why we need the prime function from the last exercise or the last 2 exercises back. So we first need to check if the number is prime. So we're going to say if is prime, I believe is the name of the function that we wrote previously, is prime of prime, if that returns a true value, right? And we do have a prime number. If prime is a prime number, now we are going to check if it's evenly divisible into n. So now we need to check again, and we need to say if n mod prime equal to 0, right? Evenly divisible. Then we are going to print line prime. And now, after we print prime, well, we need to, so we printed the 2 in this case, right? So let's run through this. Prime is 2, starts out 2. N is 18, so this is not true. This is true, while true, so this is going to go regardless. And then we're going to say if is prime of prime, which is 2, this is going to return a true. So we're going to come in here and we're going to say if 18 mod prime, so 18 mod 2 is equal to 0, that is true. So we print out prime, which is the 2. And now we need to turn 18 into 9, right? Or another way to say that is we need to make n not equal 18 anymore, but equal 9. And so how can we do that? I guess we would divide n by prime, right? Divide 18 by 2. So I'm going to say n is equal to n divided by prime. So n is equal to n divided by prime. That turns n into 9. And now what do we need to do? Well, we need to increment prime up from 2 to 3 so that when it iterates again, it could run the same algorithm. And now the question is should we increment this prime number, this number prime, or possible prime, only when this is true, or should we increment this possible prime always, right? So I think that after thinking about it for a bit, let's say we're here on 4, right? The prime number is incremented to 4. If it's prime, that's not true, right? It's not prime, so this is not true. So if we put the prime plus plus inside of this if statement here, then our algorithm wouldn't work, because we do want to increment 4 to 5 so that we can come back in and test the number 5 to see if n is evenly divisible into prime. So we want to go ahead and put prime plus plus out here, right? Outside of this if statement, inside of this while true. Alright, and so I guess the last step is we need to break out of this while loop when n is equal to 1, right? So we could have an if statement in here saying if n is equal to 1, then break. And of course breaks out of the closest while loop, and that's this one here. And if n is equal to 1, then this outer while loop is also going to break. Ooh, I'm just wondering, do we even need this while loop here? No, I'm sorry, we don't even need this while loop here. So we can forget about that. We can forget about this. And I believe that's the algorithm there. I might be wrong, but that's the general outline of it.